In this video, we are going to see how to turn this circuit into Norton equivalent circuit and Thevenin equivalent circuit. Now let's look at the standard pattern of the Norton equivalent circuit and Thevenin equivalent circuit. For Thevenin equivalent circuit, we have to have this. Here we have to have Thevenin voltage, Thevenin resistance, and also the load resistance. Okay, so this is going to be Thevenin voltage, and this is R Thevenin. Okay, R Thevenin should look like this. R Thevenin, and here we will have the load resistance. Okay, so this is the standard form of the Thevenin circuit, Thevenin equivalent circuit. Now the Norton equivalent circuit, we will have current source. So here we will have current source, and also we will have Norton equivalent resistance and then load resistance. Okay, so here we will have the current source right here, and then here we will have the Norton resistance, and here we will have the load resistance RL, and this is IN. Okay, and these are the two standard forms. This is Thevenin, and this is Norton. Okay, let's start with Thevenin first. So for Thevenin, what we do is first we cut off the load resistance. So if we cut off this part, we are going to have this part alone, right? So we are going to redraw this circuit. Here we will have this circuit right here, and then this is going to be open because we cut this part off. So this is going to be open, and then here we are going to have a line like this, and then here we are going to have the resistance, and also this resistance, this voltage. Now if you cut this part off, this resistance doesn't do anything, right? Because this is an open circuit, so we can eliminate this resistance, 7 ohm resistance, we can eliminate that one. Okay, and here we will have this voltage source, 12 voltage, and here we will have this 3 ohm resistance, and this is 6 ohm resistance. Now the voltage across this one, this open circuit, is going to be the VThevenin. So let's put VOC, and if we find this one, that's going to be the VThevenin. Now to find this voltage, we can do the voltage division, and if you remember, voltage division is basically we multiply this voltage source with this resistance over the total resistance. That's going to be 9. Okay, and if you do that, that's going to become 3, 2, then this is going to be 3, this 2, then 4 times 2, so this is going to be 8 voltage. So this is going to be the VThevenin. So V open circuit is equal to VThevenin, and that's equal to 8 voltage. Okay, now we have found out the VThevenin. Now to find the RThevenin, what we do is we short circuit this one. We short circuit the voltage source. If there's a current source, we remove the current source, like we treat it as open circuit, and if it's a voltage source, we short circuit that one, right? So we short circuit like this, and we will bring the other voltage. Okay, other resistance. So there was a resistance, we remove that one initially, so we will bring that one back, so that's going to be 7, and from this one we find the equivalent resistance, and that's going to be the RThevenin. Now you can see these two are parallel, right? So when we have parallel resistance, we can do the product over sum. So product is 6 times 3 divided by 6 plus 3, so that's going to be 8 over 3. We will have 2 ohm resistance. Okay, so the equivalent resistance for these two is going to be 2 ohm. So now we can get rid of this part and replace this one with 2. Now we can see this 2 and 7 are in series, so 2 plus 7, that's going to be 9. So R Thevenin is going to be 9 ohm. Okay, and R Thevenin and R Norton are equal, so we can say R Norton also equal to 9 ohm. So now the Thevenin equivalent circuit is going to look like this. For this VThevenin, we are going to have this voltage. We can replace this voltage, that's 8 voltage. And for this R Thevenin, we found out that is 9 ohm. So this is going to be 9 ohm right here. Then R load resistance just remain as it is. Okay, because we don't have any value, we just keep this one as it is. Now to find the Norton resistor, like here we have the Norton equivalent circuit. Now to find the Norton equivalent circuit, you can do one thing, like you can do the source transformation. If you do the source transformation for this one, you're going to get the Norton equivalent resistance. Okay, but from this one, let's see how to derive from this one. Okay, let's get rid of these parts. Let's get rid of all of these things. Okay, now we are going to derive our Norton equivalent resistance. So this is our original resistance. Now what we do is we do the same thing, but we don't keep this one as open. Now what we are going to do is we are going to close this one. We are going to cut this part off, but we are going to connect that part with a wire. Okay, here let's draw the circuit. Here what we are going to do is we keep everything as it is, but this is going to be just wire. Okay, and here we are going to have the voltage source, resistance, and here we have another resistance, and here we have the line right here, and here we have a 6 ohm resistance. Let's draw everything. So this is our voltage source, that is 12 voltage, and here we have 3 ohm resistance, and here we have 6 ohm resistance, and here we have 7 ohm resistance, and we short circuit this one. This is going to be ISC, and if you find this ISC current, that's going to be the I Norton. Okay, now let's see how we can figure it out. Here what we can do is we can do the source transformation for this one, this 12 voltage and 3. If you do the source transformation, 12 divided by 3, because V is equal to IR, therefore I is equal to V over R, so 12 divided by 3, that's going to be 4 ampere. So here we are going to have 4 ampere. Okay, let's redraw another circuit. Here we are going to have 4 ampere, and also we are going to have this 3 ohm resistor is going to be parallel right now, and also this 6 ohm resistor remain as it is, and here we will have 7 ohm resistor. Now let's go ahead and plug all these things. 7 ohm, 6 ohm, and then actually this 6 ohm, this is 3 ohm, and here we will have the current source right now, because after we do the source transformation, this is going to turn into current source with 4 ampere. Okay, so this will become 3 ohm, and this is 6, and here we have 7, and this is our ISC. Now we can combine these two together, because these two are in parallel. We can do the product over sum. If we do that, this is going to be 2, because 6 times 3 divided by 6 plus 3, that's going to be 2 ohm resistance. Okay, so we can replace this one with 2 ohm resistance. So we will have this one 2 right here. Now 2, 7, and this one is right here, and now that's it. We found out equivalent resistance, and this one is going to be just 9, right? So after that we can write our I Norton. That's going to be just, oh, I had to find out I Norton, because ISC is the I Norton. Here we can do the current division. ISC is going to be current division. For current division, what we do is we take the other resistance, that's going to be 2, divided by the total resistance, that's going to be 9, multiplied by the current source, that is 4, and if you do that, it's going to be 8 over 9. 8 over 9 is going to be the ISC. Okay, so this is going to be the I Norton. Okay, now we can replace this I Norton with this 8 over 9, and R Norton is going to be equivalent to R Thevenin. We already found the R Thevenin. That's going to be just 9. Okay, and here you can see we should have directly do the source transformation. If you do the direct source transformation for this V Thevenin, that's going to give us the Norton equivalent resistance. This Thevenin equivalent, if you do the source transformation for Thevenin equivalent, you are going to get Norton equivalent. Okay, and that's how we do this kind of problems. I hope this helps. Thanks for watching.